previously we talked about how the stream cache was set up to mostly handle transmission of graphics data efficiently from the server to the client. We also talked about how we interleave this other data along with the graphics data. So now this other data that we interleave comes from our assembly tree. So the assembly tree is created to fill a gap between the basic stream cache geometry, which does not have a concept of a scene graph or any hierarchy, and build that on top to provide those functions of the scene graph that people have come to expect from a graphics system. So the assembly tree has a couple of main concepts that we're going to talk about. So the first is nodes, and nodes can come in a couple of different varieties, those being a product occurrence, part, and a body. And the nodes maintain a parent and child relationship with each other. Each node can have attributes. It can also have PMI, and the concept of CAD views are also nodes. So what we want to do here is we want to be able to recreate this hierarchy using our assembly tree and transmit that hierarchy down to the client so that when we interact with the scene on the client, we get an expected behavior. So for example, if we set the color of a node with children, that color is going to trickle down to all of its children. And the assembly tree authoring is what facilitates that on the server. So a couple things to note here. So in general, leaf nodes are going to reference mesh instance IDs or models. So let's talk about that. So in the case of a single monolithic model, the default, each leaf node is going to be such like a body, and it's going to reference a mesh instance ID, and that is actually what's going to get drawn on the screen, is this mesh instance. Now, in the case of a shattered mode, if you think back to that lesson where we talked about how the models don't actually contain any geometry, they only contain links to other models. So this is what facilitates that. So in that case, we're not going to have any bodies in our model. We're just going to have these links to other models, and that's what facilitates that linking aspect, is this assembly tree. And now the assembly tree is authored alongside the geometry. So they're two separate entities, meaning that you're free to not even put in an assembly tree if you didn't want to. However, all of the operations on the client, such as setting colors or materials, that nature, rely on an assembly tree being present. So the assembly tree is intimately linked with the client. So this picture kind of shows how it's laid out. So we have the model, which is our topmost container in the ESC. We've talked about that. Now, one other thing that the model contains is this assembly tree object. Now, the assembly tree object is simply a tree structure of nodes. So we get by default a root node, and the root node is just the starting point for our hierarchy. And from there we start to attach child nodes, and each child node has a number of attributes that we author onto that node. So what are these attributes that we author? Well, there's a whole bunch that we can put on. So we can put on measurement information. So if you remember back to when we created face elements, that would tell us how the faces and lines were situated or presented on an object. And now we can attach attributes to a node, which will tell us such things as like the length of those lines or the area of the faces. So we attach these attributes to these nodes. And if we take a look in the documentation, we can see there's a number of things that we can set on nodes. So for example, we can set things like cylindrical measurement data on a node, face measurement data, we can set the local transform. All of these objects, all of these attributes that we set on the node are then sent down to the client when we load the model tree. So the client will create that connection with the server, start receiving the graphics data, and also start receiving all of the model tree data. Now, one thing to note here that most of this data is only sent to the client on demand. So you can imagine there being lots of data that we're building up. So for example, we may build up, we'll have a node that represents such thing as our cube, and we'll attach all of our measurement data onto that cube. And then when we instance that cube, we also point our assembly tree node to a reference of our cube, so it can pull out that measurement data, and we don't have to specify that every single time we instance a cube. So the assembly tree also helps us with our instancing by allowing us to reference other nodes that contain mesh information. So that's one thing we do want to remember. And then on the client, when we try to measure, we will look at the sort of the mesh node attached to our mesh instance node to get that measurement data out. So a couple of other things that we want to take a look at while we're here. Setting the node name, that will trickle up into the client and say what in our assembly browser what we'll see. So if you remember back to the model class and we got the node name, it will send this back. We can also set units on particular nodes, and those can vary by node, so you can have multiple units in the same file. So one thing to note here, so for example, we have like the set part method, and that's how we would link up, say, a instance node to a particular part, so that it can share that measurement data. Okay, so now let's talk about how we insert our mesh instance into the assembly tree. So you can see here we have the assembly tree top level object, and we have our root node. So now what we're going to do is we're going to insert our instance as a child of the root. Okay, so we create the child node, and we set the type to body instance. And now what we need to do is we need to associate our mesh instance key with this body instance. And we do that using a mesh instance include. So now what we have done, we've instructed the assembly tree that this particular child node is associated with this particular instance key. Now one thing we do need to note, we do also need to specify this transform matrix on our child node. And the reason for that is that by default, the transform data for each particular instance is not transmitted down to the client in order to save bandwidth. But in some cases, this transform data is needed. So we need to associate this with this particular node so that the assembly tree can access it if it needs to for certain operations.